In the preceding video, we saw that there are 6 times 5 times 4 times 3 ways to choose 4 from people from 6 and line them up in order for a photo. And that this can be expressed as, this number can be expressed as 6 factorial over 2 factorial. And more conveniently for the idea of formulating this, 6 factorial over 6 minus 4 quantity factorial, which leads us to the n factorial over quantity n minus r factorial when we're choosing r out of n in order, number of permutations of our objects chosen from among n without replacement, and this notation also. Now we want to ask, well, okay, what if we just wanted a group of 4 people? How many ways could we order? Well, how many ways could we order a group of 4 people? How many groups of 4 people can we get out of our 6? In a group of people, we don't worry about order. If we want to order them for some reason, then we're back here. But if we have 4 people, it should be clear that there are, if we want to put them in order, there are 4 ways to choose the first person, 3 the second, 2 the third, and 1 the fourth. And that gives us 4 times 3 times 2 times 1 possible orders for every group of 4. Well, 4 times 3 times 2 times 1 is just 4 factorial. If we want to know how many possible groups of 4 there are, we were going to divide the number of ordered groups of 4 by the 4 factorial ways each group could have been chosen. So here's how many ordered groups there are of 4. Here is the number of ways each group could have been chosen in order. We divide this by this, and this tells us how many groups we have of 4. That's called combination. A combination of 4 people chosen from among 6. Okay, the calculation, well, one straightforward calculation. This is this numerator, 6 factorial divided by 2 factorial, as we saw earlier. And the denominator is just 4 factorial. So we're taking 6 factorial divided by 2 factorial, dividing that by 4 factorial. And of course, we write that as 6 factorial divided by 2 factorial times 4 factorial. In terms of just the numbers 4 and 6, this is 6 factorial. The 2 factorial is 6 minus 4 factorial. And the 4 factorial, of course, is 4 factorial. Okay, so we can see that this is just this divided by the 4 factorial. This leads us to the general expression for the number of combinations. The number of combinations of our objects chosen from among n without replacement. Although we really don't have to say without replacement, we understand that combination means that we're doing this without replacement. In any case, this number, or this calculation, is n factorial over n minus r factorial times r factorial, where instead of the 6 people we're choosing from, we're choosing now from n people. Instead of choosing 4 people, 4 occurring here and here, we're choosing r people, so r occurs here and here. That's our formula for calculating NCR. Now, as you'll see soon, Pascal's triangle can be used to represent this number for small numbers of objects, but here's the general way we calculate. Okay, now an application of this is how many 4-element subsets do we have of the set 1, 2, 3, 4, 5, 6, 7. We'll do a brief video subsequent to this to illustrate that. Okay, if you're still with us, the address at which you can find access to well over 2,500 videos, more than 300 hours, is http://vhmthphyd.vhcc.edu/vmenu.html. Videos covering all college transfer courses taught at my institution in mathematics and physics, including calculus-based engineering physics, up through multivariable vector calculus and introductory ordinary differential equations.